Good evening. Good evening, sir. I am John Sheldon Olivar. Together with my partner Emmanuel Manatad, we are from the section G2C, and we're tackling about the topic recommended construction of watertight bulkheads as per SOLAS regulations. So, let's start off with the first slide. So, our first slide shows the slides that we're going to show to our report. So, slide 1 includes what is SOLAS. Slide 2, definition. Slide 3 is key aspect. Slide 4 is important consideration. So, let's proceed to our topic. What is SOLAS? SOLAS is more commonly known as International Convention for the Safety of Life at Sea. So, ang SOLAS kuno is importante for International Maritime Treaty, establishing minimum safety standards for the design, construction, equipment, and operation of merchant ships. So, ang SOLAS kuno is in charge sa overall safety. The convention's primary goal is to enhance maritime safety and prevent accidents at sea. So, as I said ganina. So now we're going to proceed to the second slide. So, the first paragraph, according to SOLAS regulation, watertight bulkheads should be constructed with a design that ensures they can withstand significant water pressure. So it explains that SOLAS has its standards when it comes to ships building. As it stands in the name of it, it aims to provide accurate design and measures to the ship that could withstand strong pressure that a ship could encounter every day. So, as I said ganina, na in charge sila sa safety sa mga marino. So, it includes the designs of the ship. So, the second paragraph is typically using thick vertically stiffened platen and should be positioned based on the ship's size and intended use. Must be located between 5% to 8% of the ship's length up forward perpendicular. So, explains, so imagine a ship's backbone, a strong, stiff structure running along the bottom. This backbone often made of thick reinforced metal plates like platinum, but usually steel is crucial for the ship's stability. So, steel jud gigamiton ana nila kay gaan sad and lig-on sad. And strength, its placement is important. It's usually positioned somewhere between 5% and 8%, as I said ganina, of the ship's total length from the very front and bow to the very back stern. The exact spot depends on the ship's size and what it's used for. So, this careful positioning ensures the ship is balanced and strong enough to withstand forces of the sea. So, as I said in the first paragraph, that the SOLAS is in charge for the design and measures of the ship to kuan sa safety. So I'm going to continue the last paragraph. So the last paragraph is all openings within the bulkhead should be fitted with the watertight door or closures that can remotely operated and monitored for proper sealing. So it explains any holes or openings in the ship's strong dividing walls or bulkheads must have a watertight doors para ma-avoid ang breaching sa tubig. These doors can controlled and checked from distance to make sure they're completely sealed. So, timely check up jud ang kinahanglan ana para ma-ensure nga walay tubig ang makasud sa barko. So, and for the last two topics, my partner Emmanuel Manatad will continue to report we'll continue to report our last two topics. Thank you.
Good day, sir. I am Emmanuel Van B. Manatan from Section J2C. I am the partner of John Seldon Olivar, and my topic is all about key aspect of constructing watertight bulkhead as per SOLAS. So, what is SOLAS? SOLAS stands for Safety of Life at Sea, or SOLAS in short. In constructing watertight bulkhead as per SOLAS, it must have high steel plating with appropriate thickness based on the ship size and anticipated conditions, vertical stiffeners to enhance structural integrity, and water to resist water pressure, consideration of the bulkhead location and potential that may force it to encounter. So, what are the placement of bulkheads? Collection of bulkheads located between 5% to 8% of the ship's aft of the forward perpendicular. Machinery space bulkhead situated at the ends in the case of the damage. After peak bulkhead enclosing stern tube and rudder, trunk, and watertight compartment. So what is my explanation for that particular slide is when you talk about constructing watertight bulkhead, it focuses on material and constructions. So it must have high quality steel plating, so that the thickness of this plating is crucial, and it depends on the size of the ship, which is a thicker plate is needed for larger ships and heavier loads to withstand the pressures, and vertical stiffeners. These are added to the bulkhead structures, so they improve the bulkhead strength and ability to resist the water pressure, preventing collapse in case of flooding. The third is location and forces. This placement of bulkhead needs to be careful and needs consideration, because the design must account for the bulkhead's location within the ship and the potential forces it will experience. So, bulkhead placement. These specific locations are needed so that collision bulkheads, as I have said earlier, 5 to 8%. This bulkhead is strategically placed so that it protects the ship's integrity during a collision. Then the machinery space bulkheads. These bulkheads are positioned at the ends of the machinery space. The purpose of this is to contain the potential damage or flooding within the vital area, preventing the water to spread around the ship. The third is after peak bulkheads. So this is situated in the rear of the ship. So this prevents water from entering these crucial critical areas that affect the ship's maneuverability. So in short, SOLAS regulations mandate the construction of watertight bulkheads using strong, high quality materials, strategic placement to ensure the ship's safety and prevent catastrophic flooding in event of damage. These specific details of construction and placement depend on the size and type of ship. So that is the explanation for the first slide. And for my second slide, watertight doors and access. All openings in the bulkhead must be fitted with watertight doors or hatchers with reliable closing mechanisms. Doors should be capable of remote operation from the navigational bridge. Visual and audible affirms to indicate door status, testing and maintenance. Regular inspection and testing of watertight materials, watertight doors, and bulkhead to ensure proper function. Periodic hydrostatic testing to verify watertight integrity. So what that means is that watertight doors accesses all openings secured. Any openings in the bulkheads must be fitted with watertight doors or hatches. These doors and hatches must be reliable with closing mechanisms to ensure watertight seal. Remote operation. This is crucial because the doors should be controllable from the ship's navigation bridge, allowing for more remote closure and emergency situations. So, testing and maintenance. Regular inspections. This must be done because watertight doors and bulkhead require regular inspection and testing to verify that they function correctly and maintain their watertight integrity. Hydrostatic testing. Periodic hydrostatic testing is a more rigorous method to confirm that the bulkhead and doors can withstand water pressure without leaking. This is important to ensure that the ship's overall safety is not compromised. So, in short, or in the essence, these points build upon the previous information by emphasizing that watertight integrity of the bulkhead isn't just about structure itself, but also that it includes the proper functioning of the doors, access points, and a robust maintenance and testing schedule to ensure continued